Hello, my name's Chris, it says on the slide. I'm a developer, been one for about 25 years, pretty much working in financial systems, calculation engines, bit of graphics, that kind of stuff. So a bit of context for you, kind of the kind of things I've seen and heard. So no embedded, that kind of thing. So that's kind of, I guess, set in the background. Yeah, 10th year, 11th year at ACCU, so it's good to be here again. Nice to be back with a nice bunch. So what's the premise of this talk is basically about monoliths, architecture, and kind of delivery technique, which we'll kind of get to a bit later. So it's a game of two halves. And yeah, we'll kind of like look through coupling, large-scale type effects, and then we'll kind of look at ways to kind of deal with that, I guess, a little bit further on. So if that doesn't sound like the kind of thing you're interested in and you want to sort of move and go to another talk, I'll kind of like turn my back and then we won't see what you can move out. Oh, is that you just winding me up by moving? Thank you. Thank you. Okay, so monoliths. Let's have a little chat about what they are. I think it's fair to say that the term monolith's kind of a bit of it's a bit of a pejorative. It's very much seen as a detrimental kind of comment, either to describe code or architecture. So I thought I'd kind of, have a read of the dictionary, remind myself exactly what a monolith is, because I think it's a little bit more woolly in the software world now. A large single upright block of stone, especially one shaped into or serving exemplar a monument. Okay, it's not really, doesn't feel like that's the kind of the metaphor we're kind of aiming for, although maybe. A large impersonal, political, corporate or social structure regarded as indivisible and slow to change. I think that kind of sounds a little bit more like the kind of monoliths I think we're talking about when we're trying to be a little detrimental to our code base. So yeah, I think we're kind of like going to focus on, in particular, this sort of latter bit here about slow to change is kind of like the main part, I guess, of what we're, what part of the metaphor, I guess, we're kind of like looking at. Anybody who's kind of, I guess, I think if you think of monoliths, it feels to me that if you want a visual representation of what it is, I guess this is the thing that we tend to have in our minds. Certainly for me, this film was older than I am, so I feel good about that. But certainly, that sort of solid monolith with the monkeys splashing around and doing stuff. But just that idea of something as being this sort of faceless kind of blob of something, we have no idea what it's made of, perhaps, or it's kind of quite opaque. I think it's kind of quite a good. That's generally kind of, I suppose, what I'd sort of have in my mind when I kind of like think about these things. No idea of perhaps what the structure is, what it's made of. It might actually be made of polystyrene. Might be really light. Don't really know because it's just it doesn't reflect light. But yeah, I think that's kind of generally I think what we kind of see. Although apparently there's a Spinal Tap one, which I'll need to add in next time. Thanks too. All right. Thank you very much. Okay then. Cool. All right. So kind of moving a bit more towards the kind of software-y kind of scheme of things. I think, looking back, kind of where the kind of term monolith, or certainly applying to systems, it feels like days of mainframes, which I'm blessed never to have kind of dealt with specifically. Has anybody here kind of, come from that world, been worked on really old? Yeah, I thought, exactly. So yeah, again, this kind of like idea of like, single kind of box kind of gets delivered and with kind of everything on it. It's it's the hardware, it's the software, it's kind of, it's everything. But even in the thing I'm kind of more used to, home computers, it's kind of where I started out. Again, that idea of you get delivered a box, and in this case, it's like the screen, there's tape deck, keyboard, everything kind of all in one piece. And so the solution that was delivered to the customer was kind of this singular piece of hardware and the software. The choices that you had in terms of implementation, languages are quite simple. Probably, if it was an Amstrad, it was probably assembler or basic kind of thing. I'm not aware of there being many Pascal, C compilers, that kind of thing. As a hobbyist then, I didn't really kind of understand that world, but again, it feels like they were quite, restrictive in terms of kind of what you did. But basically, if you had that and you wanted something else, then you kind of had to change everything. It was like, it's kind of an all or nothing kind of thing. So again, it's kind of a sort of a block. It wasn't kind of that customizable, that kind of thing. But I suspect, kind of in the mainframe thing, you could probably bolt on some tapes and God knows what else eventually. But yeah, it still feels like a sort of that kind of black faceless sort of box of stuff. So that's kind of where we started out. And then I guess it's kind of like, I think it's sort of maybe diverged a bit in the years. Maybe it's kind of less monolithic, even though we still talk about this kind of thing. I guess now, this is word 2, so certainly in terms of like monolithic applications, this kind of single application. Although any of you who programmed in that day will probably remember overlays. I'll probably give somebody some flashbacks about stuff. So, or even, even word for Windows, there was still stuff separated in DLLs, but I think people still tend to think of it as being this, atomic piece of code and application. So, once you're using a runtime library that's a shared library, is it still monolithic, or is it kind of, is there shades of monolithic? Is it sort of dark grey rather than black? I don't know. And similarly, kind of, as we sort of start to separate the mainframe out and kind of, databases in a separate kind of, on a separate box, but we're still delivering this web application, which might be a single ISAP extension if you're on IIS, or it might be a single web application. It might be broken up into some bits, but ultimately it's still kind of a single deployable thing. So the fact that these two things are running on a separate box, is that still monolithic? What kind of sense is? I kind of still think that these two things are still likely to be really tightly coupled in terms of procedures and delivery. So I don't know. Straw poll? Do people still sort of think of maybe this kind of thing as being fairly monolithic, or am I kind of, okay, shades of kind of stuff. So I think we've kind of moved away from the physicality side of it and say more into the kind of delivery kind of aspect of it. Although I should say Mongo is still delivered as a single binary executable, which I actually really like because it's great for automated testing, because you can basically fire it up, throw some stuff in it, and shut the process down, and you don't even have to have everything's in memory. So, that's kind of a good thing. It's a kind of example. So monolithic services or processes. Is the kind of thing I'm dealing with. This is something I got to meet. Decade or so ago, working in a financial institution. It was a classic kind of process where responsibilities grew, certainly over quite a few years. This thing was called the scheduler. It's like, had its own name within the entire system. It was like the heart of a calculation engine, because it used to monitor for feeds that came upstream, and it would decide what to process and kind of when to process them. There was a computing grid. It was a grid computing kind of platform. It would manage what servers were out there. It would spawn, or at least spawn processes, manage the lifetime of processes on remote nodes. When feeds were available, they'd all be processed in memory, heavily multi-threaded, basically taking in large blobs of XML, processing them, turning them into other objects, serialize them out to the grid, pulling results back. That's all kind of done in process as well. Aggregation, saving, real classic kind of, monolithic process. Certainly quite difficult to get into. And the reason I was hired, because funnily enough, this thing, started off dealing with thousands of trades and hundreds of thousands of trades, and when it reached 1 million, started running out of memory. This thing was like busting at the seams, but it was still kind of, unfortunately, one single process, and even restarting it kind of, wasn't necessarily, restarting the feeds and stuff. They had to restart the process, that kind of stuff. So I think this is the kind of, thing that we kind of get to, and we kind of want to tease apart. But that's kind of the sort of larger scale of things. Lots of responsibilities, bits and pieces. And then I was sort of thinking, can you kind of extrapolate this idea further? I mean, does if we sort of think again about this kind of like structures and kind of slow to change, the dictionary definition says, that's even at kind of an organizational level. And I think, you could possibly even think of even entire enterprises as being, described as a, monolithic entity. The system I've just described, there was a time when they had to upgrade 9 separate systems all at the same weekend, because they didn't have sort of service contracts and they were relying on certain bits of data. Somebody wanted to change or format a piece of data, and that rippled across everywhere. So there's 9 systems. Some of them are internal, some of them are external. As I'm sure you can imagine, trying to get everybody to release on the weekend, it had to be a weekend because it's banks and had to be out trading hours. Every weekend would come, and for one reason or another, somebody wouldn't be ready, or somebody had snuck in another change because, funnily enough, we couldn't sit around or people couldn't sit around and wait for things to happen, so they'd always squeeze something else in or find another bug. So for a few weeks, this whole kind of dance went on as everybody goes, "Are we good to go?" No. So, this sort of idea that entire organizations are kind of can be seen, as entities, because the systems are so sort of tightly coupled through, types of data and stuff. Similarly, date formats is another thing. Just having dates that came through in could be local time rather than ISO time, flowing around the system, but nobody quite knows where they come from or where it goes. And if you want to chase it, you don't know who to kind of chase. And so it's quite complicated. And so we kind of come to the darling of the architecture world, which is kind of Micra Services. Loads of stuff been written about it, way more than what I can say about it. But this sort of tangled spaghetti mess kind of thing is definitely something which is something, it feels like you could easily get yourself into. An organization that doesn't kind of quite understand perhaps the intent, which was about sort of decoupling deployment and teams and delivery. Again, we've basically just made lots and lots of smaller messes, but often they're still kind of coupled to a certain degree. And so that's still not going to save you. If you don't understand kind of, I guess, the fundamental reason, the coupling that you're trying to deal with, then you kind of end up with the same kind of thing, with everything attached to everything else. Particularly when you have some critical services, such as security, authentication, that kind of stuff. If you have one of those everywhere, then everything kind of gets bound into that. It's kind of, I don't know if the picture kind of comes out quite well, but it's sort of the back of somebody's rat's nest of a rig. If you ever worked in a server room, that's quite an unpleasant sight to have to deal with, I guess. Right, so premise of this talk then is that aspects, this is not so much about architecture per se, in terms of, structures, a code, the fact that you've got binaries, what people might talk about monolithic, but it's more about the techniques we use to deliver features within software. So although we talk about, people talk about things, monolithic architectures and kind of how bad they are, I've worked in quite a few that actually weren't that bad at all. We managed to deliver stuff on a frequent basis. It's not the architecture per se, but the way that we go about delivering the features within it and the techniques that we use to deploy and test and that kind of stuff. So basis of talk is it's not the architecture that's monolithic, it's the delivery process that we need to fix, possibly more than. Our architecture might have other reasons, but certainly in places I've seen, the delivery process is something that needs fixing equally as much as, or if not more than the other aspect. This, I think this is a train in South Africa, I think it is, and it's like kilometers long. And I thought it was quite a nice sort of picture, that idea of effectively batching up, units of work into, batching up features and basically trying to get them all out the door all at one time. This idea of, release trains. But this thing is a huge long train. I mean, you can imagine how long it probably takes to get started. Probably doesn't stop very quickly. But it's the fact that, like, kind of, from an efficiency perspective, which tends to be what enterprises are trying to go after, this sort of assumption that if all our people are working 100% efficiently, the organization must be working at 100% capacity and we are being efficient, isn't true. But that's what they're looking to do, is they think that by batching everything together, that's the most efficient way to get stuff out the door. And I think more recently, people like Dan North and various other people have kind of started to say, actually this isn't true in manufacturing. There's things that we can learn from there, and we can apply them to software as well. We'll look at, so kind of a bit of background. So let's kind of look at some of the sort of techniques and things that we can use to try and kind of get stuff out the door a bit quicker. Any questions so far? Observations? Good. Coffee hasn't kicked in yet, I guess. That's right. Right. So how do we break this kind of thing down? How do we break this kind of like monolithic delivery process down? What's the things we kind of should focus on? If there's one thing that kind of, I guess, principle, takeaway, it's this idea of breaking stuff down into smaller chunks of work. Pretty much everything, I think, that derives from this need to try and deliver smaller units of work, break stuff down. So in the case of the train, basically if the train stops for any reason, that's it. You don't get anything out of it. In terms of sort of delivery value, everything all comes right at the very end. Up until that point, you kind of haven't really got anything. Whereas this idea of kind of splitting stuff down into smaller pieces of work, we have the ability to deliver a bit. And I realise that in a lot of cases, the notion of what value is quite intangible. If Tom Gill was here, he would definitely criticise me for saying that and say that everything can be measured, and he's probably right. He probably could come up with a scheme for giving some value to some small piece of refactoring. It probably would cost more than the actual delivered value itself in the refactoring, but he's probably right. We probably could come up with terms if we needed to. And so the notion of value is often quite intangible. End user features is kind of one thing, we see that. But when it comes to kind of even internal stuff, monitoring and support and operations and even just kind of refactoring and improving the design and all those other like little things that we kind of need to do, there's still, there's value in them. And the quicker we can kind of get them in there into production, the quicker we can effectively learn about them, particularly if we've broken something or we've changed something or something's happened. Faster feedback is pretty much the thing we're after. And some of that's feedback from customers, and some of that's just feedback about the system. So that's kind of what we're heading for. We want to break our stuff down. What do I mean by small? To put some kind of real numbers on it, I tend to look for things of around half a day to a day, which I think some people will be surprised, wonder how on earth we can kind of break some of the huge problems down into such small pieces. Not everything fits into that, but I think, in general, I think the XP book sort of generally kind of felt that was a sort of a nice, gives you a bit of time, you can get something done, get something pushed, but you have the ability to pick other work up. And that's the main thing, is this idea of, if I'm stuck in a piece of work for 3 weeks, 4 weeks, I don't have the ability to kind of get involved in something else. That kind of like, you'd end up context switching in and out. That if I break things down, I can then deliver a very small piece, and then I can go and pair with somebody else, or I can do something else, or I can, pick up another task. Or more importantly, if it turns out that the last deployment we did has broken something subtle, then we can just pick that up, fix it, move it out. There's a much better flow of change within it. We don't feel quite so pressured even to kind of, when things start taking a little bit longer. Ultimately, we can react to things much quicker. So I generally look for kind of half a day to a day. I mean, some things only take a couple of hours, and but sometimes we do still have the larger things. When we've mobbed on a big thing with a few of us, we might have spent a couple of days for something that's quite fundamental, and I'll kind of come to that. But I thought it's important to kind of give an idea of what I think small generally kind of means. So I would say that in terms of kind of principles, long before I kind of knew anything about Agile and processes and Kanban and all the kind of like modern fancy kind of terms, this notion, this is from the C2 wiki, which is pretty much the font of all knowledge for software-y kind of processy stuff. Great thing to go and look at. So this idea of highly iterative software, this notion of always being ready to ship was something which came about, I sort of kind of grew up with, but it wasn't necessarily because of a desire because we were all agile and stuff. It was more because there was limitations within the tools, like branching, for instance. When you use a really poor version control system, which doesn't support branches, you kind of have to find other ways to deal with stuff. Like how do you kind of deliver code? And you can either hold on to it or you can find other ways. But I don't remember I first came across it, but that sort of mindset of saying, well, actually, why don't we kind of do a bit and deliver a bit, and we'll merge, we'll keep things always in a runnable state right from that first kind of the get-go. That change in mindset, had a big effect, effectively, on how I wrote software, and effectively how it changed and how the product kind of evolves, and how you can then react to stuff. I didn't realize, obviously, until much later, where it kind of derived from, but it felt like it was a good position to be in. I think James Copeland had something in one of his books, like Multi-Paradigm C++ Design, where he talks about, he says pretty much after the first commit, it's all just maintenance, which again is kind of or to think of it in that terms, that basically once you've published some code to somebody else, you're immediately dealing with other people and evolution of code, and that's kind of how it goes. And again, thinking in that terms is quite different from the, well, actually, we'll take the engine apart, stick it over here, mess about with it, put it back together, and hope that there's no bits left over type approach. It's different. Waste is something that comes out of that question, and we'll kind of look at that a little bit later. I won't bother reading that, but yeah, I think it's a good kind of, again, like the small deliveries, I think it's kind of a fundamental thing to kind of live by. So let me give an example of, again, what kind of like small means. Because I think if you're in a team and you're not used to kind of dealing with that, I thought I would take through a recent example. I was working at a retail company who had a loyalty scheme. And they had this crazy idea that people might want to actually be able to share their loyalty points with somebody else. The archetypal idea was kind of, two people living together, husband and wife or spouse, partners. And basically, they should both be able to kind of use each other's points. They should be able to earn together and share together. There's some crazy notion about students in a house, but I can't imagine anybody wanting to share points money with any other student in their house, or maybe it's just the people I live with. But the idea was, this idea of being able to group together value and being able to do something with it was something they wanted to kind of explore a little bit more. So they came to us with a proposition and said, we want to be able to do this thing. And often in this kind of thing, you end up with this kind of, well, what's the smallest thing we can do? And you get into this with the MVP is everything type approach. And it's like, well, it can't, that can't be true. There must be something we can do before something else. There must be some way we can prioritize, some way we can break it down. And the other thing was about ordering, is we wouldn't often naturally think about there is a natural order to things. It's like, well, you can't do this until you've done this. Until two customers are joined together or three customers, how can you explore spending or sharing or them viewing or statements and things? And again, you need to challenge, or we found a way of challenging those and saying, well, maybe there's ways that we can work around this. If it's a small group, and initially it was a couple of people, they worked within the company, so that means they're not going to try and game the system, because they're employed by the company, so that'd be stupid. So there are things that we didn't do, not quite shortcuts, but assumptions we can make about the implementation early on to allow us to kind of break it down. So we started by saying, well, how do we kind of get going? What do we need to do? So we started off with saying, well, let's let them see their points accrue together, and we'll do that as the first starting point. So we kind of looked. This is a REST API. We look at the API. Turned out we kind of didn't really need to do anything, but under the covers we had to decide what to do about the model. They're stored in two separate documents. We're in a NoSQL database, so we need to add some piece of information to basically say that two people are together, but we don't have an endpoint to allow us to join them together. What do? So we just decided on what our model would look like. We created internally the concept of two accounts being joined together, and then we basically pushed that out. And then the way that we joined them together was just hack something in the database. We added in the extra field they needed. And initially, it was just one field. They just said, this person's sharing with that one, and that one's sharing the other one. And therefore, when it came to asking how many points they had, it would load the both of them, sum the number up, and report it. Immediately, there's kind of questions, obviously, around, hold on a second, if they're in different documents, and different document updates aren't atomic, people, there's already questions in our head around other things we're going to need to do. But hey, let's go with it first. Similarly, accruing value was nice and easy. It already worked. So we kind of added that was already kind of working because of a natural fallout of the way that the things were working behind the scenes. So they could immediately go into the shops, try things out, start spending it. The people who were calling the API that were in another app, they could immediately start exploring that, thinking about how things would work. Asking us about, well, what happens? Are there any error scenarios? Is there anything about the API that's different now to what it was before? There might be scenarios we didn't think of. And as it happens, there wasn't any kind of early on. Still part of the whole data model issue. No, it's going to change. Keep telling the product owner that there is this piece of work coming. We're probably going to have to... Next up, we're kind of into the spending. Now it starts to get a bit more interesting because we've got to deal with the fact that we're going to need to either update multiple documents or, we're kind of touching on some of the kind of more rougher edges. deal with that kind of stuff. Again, we didn't want to get into changing our whole model to change things. So as a consequence, it turned out the database supported this locking mechanism, which again, we reel back going, whoa, do we really want to go down this path? Because, it doesn't feel like it's the right thing. But hey, we've only got a handful of customers. It's not like the whole thing. We want to explore the API and see how it works more than the change. We have confidence that we know what we're doing and we can do it behind the scenes, and we will know what to do, when to do it. So that's what we did. We effectively added locks on multiple documents. Some of them we can remove the points, and as long as things didn't take longer than 15 seconds and the system didn't lock up for longer than that, then we were kind of okay. But we added some bits and pieces in just to make sure that, if we exceeded the lock time, temporarily things were kind of okay. So again, there's only a small number of customers that were affected, but again, it got us thinking a bit more about the issues that we really needed to tackle. And then finally, we kind of get to the point where we need to then talk to a whole different other bunch of people. How are they even going to set customers up sharing? How is that going to happen? And it turns out there's a different team who have to deal with admin. So then we've got like an admin API. And this is a whole different kind of side of things, because then we were into things that definitely involved error recovery. What happens if we fail halfway through joining two customers? What states are we going to be in? Can we leave it in a nice state? Do they have to call us again? Or do we have to keep track of the fact that the process was started and continue it? And again, initially, we kind of took we forced them to basically retry to complete an operation if it didn't happen, made most of it idempotent. But effectively, there were, that was a conversation we needed to have with the people using the API to find out whether that was possible or not. And we wanted to get that conversation started sooner. We didn't want to squirrel away for months changing our model and then actually realizing that even this thing wasn't going to work. So that's the point where we sort of start to introduce other teams, talking to them, joining customers, and then splitting was an interesting one at the end. That's the point where we have all of the feature available, people are using it in a small range. We then started to tackle the issues of kind of models and how we migrate. And then that, interestingly enough, brought in how do we version? Do we uplift all of our data, millions of customers? Or do we fix up on read, or do we fix up on write? And that was something we'd kind of explored earlier on, had some thoughts about, because it had kind of come out, dealing with that in a different way. So pretty much most of this work was broken down into very small pieces until we kind of get to near the end, where there was one day where we got to the crux of dealing with something internal, and all 6 of us worked through for 3 days non-stop on basically getting that one thing, because it was a feature which was fundamental to the design of the system, and everybody who was going to work on it kind of needed to know how it worked. And we did that a couple of times on some mobbing sessions, but up until that point, things were kind of working. And because we were uplifting data on the fly, we were detecting old documents, everything that we did, every refactoring we did would go out the door straight away. And everything could be delivered, in little pieces. I mean, technically, we could have just stopped at any point, maybe done something else and gone back to it. As long as the business were aware that this would not scale to millions of customers, or even joining, there were questions around how many customers. 2, it was quite easy, but what if there's like 100 customers joining? We might have had to change the model again, so they needed to go back and think about, actually, realistically, what are some of those things to think about? But hopefully that kind of gives you an idea of how you can do things in different orders and break things down and try and get stuff out the door. Yeah, that's it. Any questions? Okay. So let's deal with the elephant in the room. This magic term, emergent design, makes some people very nervous. I think I certainly have this is the term emergency design, which is where you leave it so long, the last responsible moment is well past, and you are reacting to the fact that nobody thought about anything up front, and it's a mess. So there was a really good post, I don't know if you've seen it, there was a guy, there was like a selection of things, misunderstandings about names, for instance, and it was about people's names, a blog post. And then other people started doing them. I guess it's on the lines of everything programmers should know about floating point, for instance. And there was one about addresses. So it was about postcodes and things like that. And in one particular case, there was one of the myths is a house does not move address. which you kind of think, well, clearly it can't. And this is in Switzerland, I think it was. It's a 6,200-ton building that was 123 years old, and they needed to put a railway line in, and presumably, for whatever reason, the railway line had to go through where the building was. But it's an old building, and it's, it has a massive historical, it has value, but presumably in historical reasons or whatever. So they had to move it 60 metres, and when they moved the building, they obviously moved it to a different street, so it kind of has a different address, I believe. So, it is an example of where, how does this move? I think if you think of mobile homes, they move addresses, but I guess this is more impressive, isn't it? So, but, it's kind of I'm sure that, when they designed this house, they weren't thinking, God, what happens in 100 years' time? What happens if somebody wants to move my house? It's not a realistic kind of conversation. So I think, there are some changes which you can't kind of legislate for. And similarly, sometimes value is a kind of a hard thing as well. I mean, what value did they must have had a lot of discussions, planning discussions around this. What are their options? I mean, seriously, moving a building that weighs that much? There must have been a lot of talks. Actually, do we really want to keep this building? Can we break this building down and rebuild it somewhere else? Does it have to be moved in one chunk? I'd love to know what kind of other scenarios they went through and even how they decided not to just tear the building down. It must be, it's quite interesting. But the point is that those conversations must have happened. They wouldn't have just gone, yeah, we'll just pick the building up and move it. I mean, that's wrong. So I think this term emergent design is kind of, again, it's a bit like the monolith thing. It's a bit well, if people aren't too, a bit wary of it. But, there is planning, there is an element of design that has to go in for it. But it's a balancing act between things, things cost. So it's just a really great quote from Ralph Johnson, which is, software is not limited by physics like buildings are. It's limited by imagination, by design, by organization. In short, it's limited by properties of people, not by properties of the world. We have met the enemy and he is us. There's an article Martin Fowler wrote, 2002, I think this was, something like that, called Who Needs an Architect? And it discusses the architects and people and roles. And I think it was the first thing to kind of maybe talk about architecture as being a role within a team rather than having kind of predefined architects. And there's this little conversation with Ralph Johnson kind of at the end that he has, and which is kind of where this comes from. And I think I think the thing that probably I think is most profound impact kind of it had on me was to realise that this sort of fascination with construction as a set of metaphors around building. We talk about building software and architecture and stuff. But coming back to the monolith, this idea in our head that we have of something kind of physical with weight and structure, affects the way we think about change. And he's just reminding us, like, it's just bits and bytes, a lot of it. I mean, yes, there is server hardware. But, particularly now, with cloud-based computing, it's like spin up VMs and Docker containers and things, all over manner of stuff. It's just so easy that even, that side's quite easy. But change is not driven by there's no physical cost to it. Effectively, it is costly, but it's in terms of time or it's in terms of process. It's design, related stuff. It's not kind of manual labor stuff. And we kind of need to remember that moving things around isn't, kind of quite so hard. We should make sure that we're thinking of things in the right term, not visualizing problems that don't exist because we're So this is in kind of something talking about system that I worked on. Mr. Love will probably remember it. I worked briefly with them. About how to kind of evolve a system in a way, starting off with something quite small, and then how we kind of, we break this up. How does kind of emergent design kind of work? What are the things that we kind of care about? So this was, again, a greenfield calculation engine project. It was a big, it was a kind of a group computing thing, bits and pieces, generally kind of .NET based. And when we started off, we did a little bit of walking through, get a vague idea for the kinds of things we thought we might need in terms of services, how we might structure things. There was a certain amount of conversation, a little bit of upfront design. We didn't go to nth degree. We didn't even necessarily pick what protocols we used. But we had a general feel for the sort of, the problem we're doing. We had a chat for a couple of days. And we kind of started our first iteration. And what popped out of our very, very first thing was this console app. And it was just a .NET console app, and it printed the number 42. It's like, we were quite pleased with ourselves, you know. It was kind of that was it. It was a starting point, you know. You ask it to calculate a number, and it kind of gives you a number. Okay, it wasn't particularly exciting, but it was kind of part of this idea of, you know, walking skeleton, which is often takes into account build and other stuff. We had other reasons why we didn't kind of go that far, but we felt we wanted to start somewhere. You know, it's first deliverable. Second and third kind of iterations, we start looking a bit more about some of the sources of data we need. How do we source those bits of data? So market data, trade data, we need counterparty data, we need this, we need that. Start thinking about how we'll piece some of that stuff in. Where do we go next? Well, it'd be nice if maybe we didn't just return 42, nice a number though it is. We should kind of maybe move a bit more. So we started to piece in some of those kind of other bits. So in our console app, we started putting some data from some other systems. And the next iteration, we printed out that we got 3 items of market data and a couple of trades and a bit of counterparty stuff, and that'd be the next one. And then we kind of move on, and again. I mean, it still remained a console app for quite some time. As like a little calculation engine, despite the fact that we knew it was never going to kind of end up like that. So we pieced little bits more in. And eventually we kind of get to the point where you know, it grows, and the size of the problem, the volumes of stuff we need to deal with means we have to bring things, other kind of aspects in. We start needing to parallelize units of work and that kind of stuff. But even though we delivered one kind of single blob, kind of exe, obviously internally, it still had structure. It had, you know, we started to use namespaces. Things that started out as just a function grew into a class, and then we grouped the classes together and we put those classes into namespaces. And then we started to say, well, some of these assemblies maybe, or these namespaces, I don't want people getting into being able to access internal things. It's really easy in ReSharper to suddenly find a class, use it, hit Alt Enter, and before you know it, you've created a reference to some, you know, kind of internal detail, because you haven't even with because if everything's in one assembly, even internal kind of like buys you nothing. So the idea of maybe using packages a bit more so that we could leverage kind of this internal mechanism so we could keep implementation details away and structure. So inside our monolith, we still pretty well sort of, you know, started to be quite well structured. And obviously we knew that parts of that structure would be pulled out. And so kind of like over time, things start getting added. We start hosting the same bits of code in a service. Again, we ended up with one service container and we hosted multiple services in there. We weren't quite sure how it was going to play with memory. We might have to split them out. In the back of our heads, but generally, it was kind of one thing. Picked WCF, because quite frankly, it, don't know, just seemed to be all right. You know, picking something, it's an internal detail. It wasn't a published interface to anybody else. We could change it. So that's kind of how we got. And then we ended up, eventually, 18 months later, well, actually a year or so later, with a whole bunch of stuff. You know, bunches, blibs of code, some software, some services, some command line tools, loads of scripts, some batch files, a bit of a Heath Robinson kind of stuff. Database stuff. Even in the database, we had schemas, separate schemas for things, break things up, give them, you know, a little bit of structure. Kind of, you know, although we had, you know, so staging and tables, things was kept in different namespaces. We tried to make that internally, so that, you know, maybe we would split things out into different data, physically different databases, but we knew they wouldn't be coupled behind the scenes. We'd be able to see that kind of coupling. So we kind of kept those, some other stuff. Some stuff we put on file system. Interestingly enough, we had 2 teams. The things that we built, first of all, were some like system level mocks for market. There was these other services that were going to be built at the same time as us. We were part of this massive program. And funny enough, as time went on, all of a sudden these other things that were going to be delivered, that we were going to depend on, didn't turn up. And then one got canned, and then one didn't change. And when we went live with version 1, our mocks went into production as the version of the service. And it was it was just so unoptimal. We were using the file system. In fact, we ran out of inodes on the file system because everything was stored as little objects. But it was like, but we got to go live. It was enough, and we'll kind of, you know, we'll deal with that, and we'll find another way. Maybe we'll kind of, it was an internal thing. We can change it. We thought we could until we found other people started accessing the file system because they realized the data was easy to reach. But it was kind of, but that's kind of, you know, it's a different kind of problem. And it's like, although we felt like we shouldn't kind of give them access, it's like, oh, hold a second, there's people that need this stuff. So this is a different conversation. you know, like, please just hold off for a minute. You know, we'll kind of, let's find out what you need, and maybe we can satisfy both things, you know, without actually giving you write access, because you definitely don't need that, but that was just a typing error by a system administrator. But, you know, so, you know, these things happen, and we kind of either roll with it and deal with it and kind of go on. That idea of storing blobs kind of on the file system has come up a few times, I think, is a nice way. When I talked about the loyalty scheme, we started out, we'd already been involved in a project that had used Mongo as a database backend, and there had been some changes at the end where it turned out there was another team in the organization who then said, we tell you which database to use. You shouldn't have done that. You should have come to us with a request, and we'll tell you which database you can use. We're like, okay, I thought we kind of knew what database we'd be using because we know what the problem is. But so there was some kind of like internal politics. So we were, you know, you get bit once bitten, twice shy. So when it came to doing something else, we decided that actually, you know, we're going to defer that decision for as long as possible. Let's find out exactly more about what we need than perhaps, you know, up front. So we just serialized data. Well, initially, we just kept them in dictionaries. And then the product owner one day said, it'd be really good if you didn't keep throwing the data away every time you upgraded it every hour, because when I'm trying to do a demo to another part of the business, I have to type things in. We're like, okay, then we'll do some persistence. So what do? We'll just serialize it to the file system as little blobs of JSON. It's fantastic. On the loyalty thing, the idea of doing that in storing in an S3 bucket, just storing blobs of JSON, you got like a few things. There's a way of kind of deciding, what does your data model look like? In particular, in that case, we still didn't know whether relational was a better approach than a document-oriented approach. There were some aspects that worked in both ways. But we didn't really want to get in broad in deciding which database and learning how to build it and monitor it and all that kind of stuff. So again, we kind of deferred it. But we knew that we could, whatever we chose, we'd be able to have access to the resources and the things we need. So, as I say, part of this emergent design thing is really, it's not about not thinking about things, it's just being really aware of what those things are, maybe what those things, questions are, keeping them tight, keeping the business people informed of the fact that you might have to deal with some stuff, but generally kind of like going with it and seeing what goes. It's not, I think Ken Beck said something about the sum total of code at the end is probably the same, but the order in which you deliver it is different. And that's the key thing. It's kind of, you might still end up at the same place, but the idea is maybe to go in a slightly different order and maybe leave a few things behind on the way. Steve will tell you there's some really hokey stuff in there that we never unwound, and that will kind of make you feel kind of a bit uncomfortable. We used a database table as a queue, which was, again, it was just supposed to be a temporary thing because we had a team. Dealing with the middleware team was hard. Trying to get them, they owned the middleware server. We felt that that would be a blocker on delivering other stuff. We didn't really want to be blocked by them dealing with that. So in the background, that can kind of evolve, and we'll start with the database table. Didn't think 4 years later we'd still be using the database table as a queue. But, you know, it's something that we can change. But it worked, it turned out. It turned out it worked an awful lot better than we needed. We didn't need the latency that we thought we needed early on. But it's cool. But, you know, later on we might do. Cool. Any questions? Or are you? Yes?
Just an observation. But you say that using the database table as a message queue throughout the thing has been a lengthy idea. It's exactly what I've done.
Well, yeah, a SQL Server has support built in for using a database table as a queue. I mean, it's an implementation detail, but yeah, it's not that bad. Just like using the S3 as a file system, as a database, by storing documents and allowing the natural file system indexing to deal with looking things up. It's, you know, just as long as you're aware of the fact that if you're using it and you're going to create strain on the database for other things, keeping it separate so that the queue's not necessary. If you're joining from the queue table to other tables, you're probably getting into elements of coupling that you might want to deal with. So that's the point where you want to, maybe you can keep them separate. So storing, say, multiple types of data in the same database for efficiency purposes, because you've already got one there, is not the same as actually you relying on being able to join the data underneath. You might want to be better to join the table a bit further outside. So, you know, those are the kind of trade-offs, you know, coupling, keeping things kind of separate, conceptually separate, even if they're in the same place. In fact, I think we did that for, there was a notification system we built, And we needed to keep the history, and we needed to keep, there's sort of like the messages that needed to go out, and they were sort of scheduled, and then there was a conversation history we needed to keep. And again, one of those actually was good for a relational approach, and the other one was more of a kind of like fire and forget, Mongo document-oriented approach. So actually we had two databases, because actually they had different things, but we started putting all of the stuff in one database temporarily just to see kind of how it looked, just by storing JSON fragments, but effectively we didn't need to join the data. We just relied on the fact that we already had some. Actually, that was one of the things that made the architect really nervous. We had an architect assigned to our team in the very early days, and they obviously wanted to narrow down what database we could use and which approach we're going to use. I don't know what the data looks like. Why are you asking me these questions? We'll find that out. That's quite, for some people, that's kind of who are used to working the way, to decide those things much earlier on. That's quite kind of a change for them. So they disappeared for 3 months and then kind of came back 3 months later when we go, now we know what we're doing. We know what we're building now. As Alan Kelly has this idea of first build the right thing and then build the thing right. That idea of first actually know what it is you're building, because it might not be quite what you think it is. Right, so this isn't a famous quote. This was me trying to kind of get my head around design. It feels like technical debt is something that somehow is tied into this approach. It feels like, often we end up with this, we end up with something that's kind of less than perfect, and that makes us feel uncomfortable, and hopefully we're in an environment where we can kind of can deal with that. The previous system, there was a thing, it turned out that some other system migration had happened, and there were customers who had the same ID in two databases, and there were only a handful out of thousands of them, and it turned out that most people in business didn't even know this had happened, because they all dealt with the data in one way, and different people dealt with things on trade systems, and we were cutting across the entire organization with the stuff we were doing. And it turned out that these things, but by then we'd already made assumptions that codes, because we'd been told, so that things were kind of done. So we ended up having to like shoehorn this process on the side somewhere that would kind of like go and find the duplicates and make something happen. And it was horrible kind of like hack, but there was a couple of really, really significant customers that were counterparties that were involved in the calculation that had to be included. The system wasn't valuable enough if they weren't included. So we shoved this thing in, and soon enough we tried to find a way to kind of deal with that and bring it back, because every time you did something, you have to remember there's this thing right over there that you've got to kind of remember. But anyway, this feels like this kind of like, if we sort of bring the debt thing down into very short things, it feels that, to me at least, emerging design is about thinking things in terms of debt. It's about, doing a little bit of an experiment that might not be right, making us feel a little bit uncomfortable, learning about it, but then repaying it. And I think that's the point. The point is that this is all about short-term effects. Being aware of the effects of what we're doing. That we're getting ourselves into a bit of a mess, but we've got to tidy up kind of straight after ourselves. We can't leave it forever. Yes?
It seems to me, just an observation, that this has some parallels with the way TDD works on a very low level. So it's more like design TDD.
Yeah, it is. So that's a good point. There's the idea of outside-in development, starting with a test outside and kind of iterating inside and then kind of making it. You're right. The value is this particular piece of functionality, but kind of how it works might not be quite right. And actually, we'll come to refactoring stuff, I guess, in a minute. But you're right. That's exactly how I see it and see the process I use. I'm a test first in any, well, as much as possible, except in bash scripts or something like that. So it's just a little bit too hard. Yes?
I'm thinking about it. I'm not sure it's about technical depth here. It's more about sufficient design. It's like it's fit for purpose for now. When we learn something new, we do something else instead.
Yeah, so I was trying not to use, because so George Fairbanks has his whole book called Just Enough Architecture, which is, and I was trying to avoid using his specific term because I was going to mention it. So he's got a great book which is about, it's about that. I think it was more about the discomfort maybe that we feel, so about maybe doing something not quite right and then kind of correcting it. It felt like it was that emotion that is attached to the debt that I was tapping into rather than
To me, it looks like
Yeah,
From thing.
yes, yeah, it is.
To know things.
But I think the thing is that technical debt is about conscious decisions to not do something right. So I am definitely not doing something I know is right, which is why the debt thing kind of feels more right to me, because it feels like I am consciously making a decision to take a shortcut in the short term to learn about a problem, knowing that I will probably have to pay that back. There's a difference from I really don't know, and there's a, to be quite honest, I know that this is never going to, almost certain this isn't going to scale, and that's, I don't know. I think it's trying to tap into that emotion of how far you go. But yeah, maybe, I haven't read George Farrow's book, so I don't know what the rest of the premise is, but I know that, his terms. And obviously Simon Brown is also a guy who's got loads of, yes, I always get Simon Brand and Simon Brown confused. Simon Brown has got loads of good stuff with his C4 model, and he's got a lot of good talks about modular architecture and stuff like that. That's kind of his bread and butter, so similar kind of thing. So I was kind of trying to avoid borrowing other people's terms and maybe come up with something myself. I don't know, maybe it helps, there's an alternative viewpoint, I guess. And the point is, yeah, we're using practical experience to drive it. So there's a certain amount of thought, we can do some stuff, but really we want experience of using it to help us drive the decision. Maybe it's more about the ordering of the decision when we decide to change something. Let's see. Cool. Yeah, so this is a famous quote, I think often gets kind of like bandied around. So part of our, so this kind of, again, sort of ties in with the kind of design, the refactoring side of things, is that idea of kind of cleaning up after ourselves. I came to a talk, an ACCU talk, one of the first times I came, by Michael, is it Michael Stahl or Michael Stahl? Stahl, I think it is. Who's, is it? Yeah, the German, yeah. Stahl, yeah. And he did this talk on refactoring, and it was at the time, refactoring was still a bit of a fuzzy term in my kind of head. I'd read Fowler's book, but he was talking about this in a wider scale. He was talking about architectural refactorings and that kind of stuff, really kind of like bigger picture stuff. It's like 10 years or so ago. But it's a really good talk because he was saying, the same principles apply. So although we move little bits of code around, within functions, and we try to make that part of the system, this kind of same concept can apply again and again at larger parts of the system. And if we think about observable behavior in terms of, a wider thing, we think about users as being the people who observe the behavior. We should be able to change the internals of the system and not affect their perception of how the system behaves. Or if we do, at least it should be in a kind of a better approach. But effectively, we can change things internally, move things around, and that's a good thing, and we should do that. We should deal with stuff. Maybe that's sort of, I think there's there's a parallel with the debt thing. But sometimes, I think whereas debt is about making a conscious decision to go away from a particular choice, refactoring more feels about, actually we've learnt more about what shape something should be. Maybe we started off putting stuff in a table, and actually what we really need is a queue to do something, and that would be a better design and a more obvious way to represent the same concept. Or the same piece of functionality, because actually people are struggling with the fact that we're doing something in a different way to how you'd perhaps have done it. So it wasn't necessarily a debt-related kind of decision. It was just we didn't know what shape the problem was. We didn't know whether we'd be going to be shoving a lot of data in there or no data, or we'd be using it to trigger commands, or So it feels that again we should apply the same thing on a bigger scale, and we should change bits of kind of architecture, fix things about. And ultimately, yeah, I like this idea of perfection being about removing stuff. And in this sense, it's about removing complexity. And that complexity might be actual complexity within the code, or it might just be complexity from misunderstanding because actually we've done things in a really weird way. And there's a simpler way to represent the same concept, using a more obvious kind of technique. So I think, yeah, I did originally put refactor relentlessly, as I do like to kind of do a lot of refactoring. I think every time I kind of learn something about a piece of code I'm working on, if I've got to change it already, I don't go out of my way to just kind of like rewrite bits of code ad hoc. But if I'm in somewhere and it feels like it's changed, and I'm trying to sort of apply that same principle to kind of like to other parts of the system. Deploying frequently is a key part of delivery. Again, this idea of small change, if we've got small changes, we should get them out there. We should, if possible, we should be able to push them out, we should be able to deliver them. Being in that kind of position of getting it in the hands of users, testers, but even internal deliveries, let's kind of get that stuff out, get that in the hand of users, let's start getting some feedback about what we're doing. In particular, operational kind of feedback, but basically get that out, get our little bits of work. And then, of course, we can then kind of like change our minds. If it turns out the stuff doesn't quite work or it doesn't work the way we want it to, then we can just, we can kind of like iterate over it very quickly. Common kind of thing I think that's sort of building up is this idea about mean time to recovery is more important than mean time between failures. Actually, let's stop trying to kind of go backwards, because actually it's often harder sometimes to go backwards than to revert. I mean, if you're in a cloud-based scenario, you can just revert to the previous version. But if you've got some stuff and you've broken it, actually put yourself in a position to fix it and deploy the fixed version as quickly as possible. If that's kind of in the world that you're working in. Think more about what things you need to put in place to allow you to fix things, change things, and get the stuff out the door. Often that's certainly a huge amount of automated testing, automated build pipelines, that kind of stuff. But it's such an enabler to be able to just kind of like go around and change and fix something pretty quickly, rather than having to then sit on stuff. And so the other part of that is once it's out there, techniques for getting feedback. So obviously we solicit feedback from our, from customers. How's this thing working? But there's other stuff as well. If you're building a REST API and your customer is a developer, you're going to need some other kind of monitoring and stuff. You want to know how the performance is changing. You want to see trends and that kind of stuff. But also, you might want to see how people are using. If it's an API, how they're using the API. There's that. I did originally have a picture of the scene from Jerry Maguire where there's a guy saying, help me to help you. And many times we end up having people that have kind of used an API, and we're sitting there watching what they're doing with this API, and they're doing random stuff, and you kind of ring them up and, what are you doing? Why are you doing whatever it is you're doing? Why are you calling this? Or there was somebody who had a trailing space on the end, and they're getting 404s. Do you not realize that you're getting thousands of 404s a day? And it turned out they had an automated test, but the actual automated test wasn't failing despite the fact that they were sending us the wrong data. And it turned out that their build process was broken, but they didn't even realize it. So there's kind of, things where us trying to spot what we thought we were looking for trends of certain things, and actually it turns out that it wasn't our system that was failing, it's people were sending us, rubbish in some environments. So looking at what they send, and then particularly when it comes to trying to make changes, trying to work out if you know roughly how people are using, or actually if somebody isn't even really using an endpoint, they might have said that they've kind of done something, or maybe they've got some contract tests internally, then you know that you might even be able to get away with changing it without having to do any kind of like backwards compatibility stuff. You might just be able to go, actually, you don't look like you're doing that, let's kind of change it. So I think monitoring is kind of, it's definitely a kind of an unforgotten thing, but it's not just from a support and an operations perspective, but just from learning how people use this, use your product. Deal with it. Right, I'll have a sip. Any other questions? How are we in time-wise? Right. Okay, so I'd say it was a game of two halves. I lied, didn't I? It's three. That's all right. So the last part is looking at, I didn't want to say anti-patterns, because that always feels a little bit too kind of harsh. It was looking at things that I've found that perhaps are misunderstood or ill-conceived, misconceived, and maybe kind of addressing some of those things that actually are barriers to adopting a more kind of iterative, fine-grained approach. So just got a couple of things that I want to pick up. I put this in specifically for Fran, so because she's you spend a lot of time in meetings at the moment, don't you? So this particular tweet I thought would rub you up the wrong way. So something I've definitely come to realise is that that what we often perceive as waste is often just a local optimization. We are, again, this notion that enterprises are looking for people to be busy 100% of the time and to effectively being, maximally utilised, that ultimately the organisation is running as efficiently as possible. This is a thing that Dan North, I think, is kind of, tackling or done a lot about recently. And I'm kind of finding it beginning to kind of get my head, I guess, around this. So, there have been times where I've been at a stand-up and somebody has talked about something. They don't do that because they think it would be a waste of their time. And they're thinking about the fact that it's their time they're wasting. Whereas, actually, if they was to put this feature toggle in and they look at the bigger picture of trying to get that piece of functionality out and switched off, that extra bit of work obviously will take them a little bit longer, but actually it might buy us some other, in terms of deployment, we might be able to get it out sooner, switched off, rather than holding on to the code and having some inventory and having this weird thing sat there on a branch, that kind of stuff. So this idea of kind of what waste is, and I think, and this thing in particular, particular comment though, about meetings, I'm sure there are places that have do have kind of too many meetings, but even just meetings in a kind of a smaller sense, just talking to other people, pair programming is almost a little meeting. It's just the two of you talking about stuff, but you're typing code in. You're allowed to type code in during the meeting when you're peering. But that idea of like what actually collaboration is and talking about things in design. And I think, again, where the emergent design thing has gone too far is people assume that you don't kind of talk about this stuff. But actually, you do. You bounce ideas off people, which we all do. We have our stand-up every day. We talk about what people are doing. People should be able to get involved in stuff. So meetings are important because, as he rightly points out, people can go off and solve problems that don't exist. We've all seen code or had features that have been added because a developer thought it'd be a really good idea, and he didn't bother to ask anybody else, whether they thought it was necessarily a good idea. But, not even if it's a good idea. It might be a good idea, but it might not be a good idea now. So I'm like, it's not we shouldn't do this ever. It's do you know what? Today we should fix this bug because it's kind of important, or we should add this thing, or we should finish this thing, and then we'll move on to it. Let's get something done rather than kind of, delaying it a little bit further and a little bit further. Because, when we all get an idea, we get a bit excited about it, and then we kind of, it soon snowballs and mushrooms, and before you know it, you've kind of, you thought was an hour might be 2 hours, and then you realise you haven't had any tests, and then it doesn't match the definition of done, and so it's just, putting talking to somebody about stuff first, and deciding whether it's value, sticking it on the backlog. Anybody can stick stuff on the backlog. It's not just a product owner thing. And whether you trim it later because it turns out that, in 2 weeks' time, 3 months' time, you decide, well, actually, we didn't need it after all. Great. But that's the waste. The waste is not kind of, put it on the background. And the waste is not having the conversation about it. The waste is avoiding doing stuff that you kind of didn't need to do. There was a product we had where we needed to add some security features into. We'd done the authentication part, that was great because the API was live, but the authorization side of it needed a little bit of, we needed to come up with an authorization model. Again, this was something where there wasn't much communication that happened within the team. And a couple of people who've worked on something before, and they go, oh yeah, I know what we need. And they built this big kind of authorization model, and they built an API for it, and they put all the acceptance tests in for it and everything. And a couple of us came back off holiday, and we kind of looked at it and went, that's a bit more complicated. You know that all we need is, in this one thing, there's just this one thing that needs authorizing now. And actually, if you look at what we planned for the backlog for the next 6 months, that's still all we need. So some people have gone, I spent a couple of weeks building a whole load of code, adding a whole load of tests. And then it starts getting awkward because you really want to rip this code out because you're about to publish an API for something that is way over the top for what you need. You've got to have an awkward conversation about maybe pulling that code back. So it's a bit more time, and then eventually you've got to take that code out. And obviously you've been running tests, and you've been factoring this into how things work. And it's awkward. And then you end up, we reverted the whole thing, put in just a tiny little thing that we needed to satisfy that part of the authorization. A year later, we still didn't get to the big kind of authorization part. Had a whole load of other features that came in, but it turned out we could do something really simple. So again, that kind of like waste, that conversation, that hour at the whiteboard that maybe we'd had, or 2 hours at the whiteboard, or even thinking we might want to head in one direction, but let's only do this little bit first and kind of see how it goes. Those conversations, those meetings are really important. A stitch in time saves 9 is an old adage. I think it's still true. The only problem is for every adage, there's a completely opposite one that blows it out of the water, but, you know, it's kind of, but I think, you know, it is, you know, design, certain aspects of it. So meetings aren't entirely a distraction. They can actually kind of keep things going. So, you know, don't feel too bad about them, but don't obviously spend all your time.
In my defence, collaboration is brilliant. That's what meetings should be for. But sometimes they're rituals
Yeah.
and telcos and technical problems. But collaboration is great.
Brilliant.
I think a different word for the thing that's supposed to be a meeting is collaboration.
Yeah, I mean, if you, the daily stand-ups, you go, sorry, go on.
Could you repeat the question, please?
Oh, sorry. Well, it was an observation from Fran that
Meetings as collaboration.
collaboration is a good thing.
Meetings for meeting's sake.
Oh.
Are pattern sakes.
Yes, sorry. The observation was that meetings, for the purposes of collaboration, is a, you know, is a highly useful thing. But just ceremonies and rituals, they're kind of like, you know, it's not as good, you know, not as useful.
Meat napping.
Sorry?
Meat napping.
Meat- Hard, yeah. Similarly, you know, the daily stand-up is a good thing where, you know, I think the first stand-ups I went to, do you think they're about status meetings and people say what they did yesterday and today, and then, you know, you can discover that it's actually about reprioritization and it's about swarming and it's about people actually saying, you know, I'm doing this thing, and somebody else being able to say, oh, actually, I'll pair with you on that. That's a kind of a big change in the way that, or actually, you've gone off at a tangent there. Let's not do that story today. Let's do this other thing today. So, you know, balancing work. Maybe we'll hold off. Having those kind of conversations is good. Yeah. This is for, I like to put this picture up for Russell's benefits, Clapham Junction, which I want to be a train driver going through there. Branching is something I've talked about here before various times. I'm not one of those people, I don't believe in absolutes. There's not, you know, trunk-based development is the absolute only way you have to do things. It's nonsense. You know, there are reasons why we have to do, you know, why branches are useful, particularly for spiking, keeping noise out of code bases. If you have to branch for release because your regulatory process or whatever, by all means do it, branch late. But generally, long-lived feature branches is what they're getting at, having stuff sat there for a long time. Basically, try and avoid that. Try and keep your code fluid. They're always ready to ship. Develop stuff in a way that's ready to ship. Actually, that was a bit I missed off on the waste. We often perceive that by adding things like feature toggles or by having a piece of ability to turn something on or off or having a duplicate or an alternate implementation is waste in the code. I mean, technically, it's dead code and we should delete it if that's the guideline that we're going for. But it's also an enabler, being able to have that in the code to be able to switch it on and off, and particularly if you can switch it on and off at runtime. That moves you into the world of A/B testing, the ability to deploy a feature on 10% of the infrastructure and keep the rest of it running the same, soak test it, see how it works. All those behaviors are possible, but you do have to do a little bit more work maybe. Maybe you have to do a little bit refactoring to allow for the fact that you have two implementations. That's not waste. You know, the waste is not being able to do it and not being able to test it and not being able to get it out there and not being able to get feedback. That's the thing that's wasteful. Yeah, we've had a couple of people who have kind of like forced us into kind of, or at least, you know, provide external influences that want you to investigate approaches to stuff. That's not the stuff we do now. So yeah. So again, branching is kind of on the same thing. Pushing stuff out onto code kind of generates waste. And so we want to kind of minimize, we want to keep our code kind of supple and kind of keep moving forward as much as possible. Yeah, feature toggles are a classic way to do that, whether that's compilation or build time or whatever. As an example, actually, of the cost of long-lived feature branches, the scheduler monolith that I kind of mentioned right back at the beginning, when we came to break this thing up, we ended up having a project, and the organisation I was working with at the time, all projects were pushed onto separate branches, and then at the end they'd kind of like merge in what was happening at other points. There was generally no merging in between. So we started this piece of work, and I wanted to kind of try and break it up, but do it. We didn't really have a main, but we wanted to work on the branch that was kind of the other project that was delivering next. Didn't feel kind of comfortable about that, so we had to kind of push our code out. But what was good about it, although this thing had a lot of responsibilities, internally it was reasonably well structured. There's bits and namespaces, stuff was, you know, coupled. It was fairly cohesive in terms of structure, and so we could kind of like start to tease little pieces out. and think about how we could kind of like break it out. So we sort of broke this thing down into little pieces, and we had separate processes that would then be fired off to do some of the work, which gave us better error recovery scenarios, that kind of stuff. But anyway, we came up with a plan. We spent a few months breaking this thing up, introducing things. We had a different grid architecture that we needed to port to. They wanted to do at the same time, so that was part of the driver for doing this work. This was all done. We were 2 weeks away from delivery, and the credit crunch hit. And then the organisation decided to go and buy one of the other people that were involved in the credit crunch who weren't so fortunate. And all of a sudden, everything stopped. And they decided that rather than finish this project off, what they would decide to do was, they said, right, that's it. We might have massive volumes. We need quick fixes, low-hanging fruit stuff to basically deal with the fact that the volume of trade data was suddenly going to go massive, possibly 2 or 3 times what we were dealing with. That was the kind of the estimate. So, of course, I put my hand up and went, hold on a second, if we finish this piece of work, this is like, this has been designed very much with obviously a bit more future in mind, with higher volumes in mind. It's like, oh, yeah, but it's not finished. It's kind of, they didn't want to take that on because historically things hadn't been gone too well. Releases were always a little bit hit and miss because they didn't, releases were months apart. Naturally, people weren't very good at releasing, so they felt there was more risk in taking this change. So it sat there on the branch, and we kind of had to make this thing that was already creaking at the seams, maybe work in other ways. And it sat there for months and months and months. I left, and then 6 months after that, a year later, it still sat there on a branch. So we've months of work effectively, lost because, effectively because it's kind of sat on a branch, and they didn't want to pull the code over. They didn't think we could kind of tease stuff out. But we'd done it in a way where we should be able to pull bits in, and we could have, if we delivered some of the changes, and a lot of them were just refactorings even, initially just pulling some stuff out into libraries, simple things, and then some other bits of work where we could spawn off a process and manage it. If they had all been delivered at the time, they would have got most of the benefit, and then the last change, or last couple of changes, obviously the risk on that would have been so much smaller because we'd have proved that we could have done it, but they'd still get to leverage it. So that, for me, was the point at which I really began to realise how disruptive long-lived feature branches can be. Not short-lived. Carry on. Yes.
How do you fit in testing with regards to minimizing branching and using feature flags?
Mostly trying to use different forms of testing, unit tests, acceptance tests. Ideally, if you can toggle a feature on and off through an acceptance test, toggle a behavior. Obviously, in an API, you can use things like passing through extra parameters, or maybe using dynamic config settings in the code. You can kind of host it, reach around, and toggle something on and off. That's generally the way that we kind of do it. Doesn't work for everything. But generally, I tried to make it configurable at runtime, just because then it works with tests. Having to have 2 sets of tests where you turn the flag on and then run the tests again, it's kind of not quite as good. And once you've kind of like built that little mechanism in, then often it's quite easy to reach around. But yeah. So generally try and avoid branching if possible. If you're going to branch, just keep them short, basically. Just keep merging. But that's a whole different talk, other people. Last thing, shared binaries. Sharing code is great. It's great to reuse other people's stuff, but I have seen it turn into a massive burden. Shared binaries, there are other ways to share code, not necessarily through binary means. So yeah, I know we'll use NuGet or package managers in a lot of cases, and sometimes we're sharing through code. Really, the thing that I found is it's the ownership that often sits around shared code. Again, in an organization, it's like, great. I mean, 10, 15 years ago, we all wrote our own thread pool. We kind of generally don't have to do that now, but we did it, and at some point we moved to Boost. We still have quite a lot. We all wrote our own logging libraries. A lot of the utility and infrastructure stuff has often been rewritten many times, and the obvious thing is that somebody moves from one team to another, and then you start pulling in a library. Fran and I had the pleasure of working on a code base. Ours was a fork of another calculation engine, and I think yours was a fork of our system, and then there was 2 other forks of that. And they had this library of bits and pieces and stuff that was shared between the teams, but nobody actually owned it. The idea was, hey, well, people will just change it as they see fit, and they will fix it. Which is a really nice idea in theory, but when it comes down to actually making the changes you need to do, and it comes down to, well, which budget is it coming out of, or who's paying for this kind of change? And actually, it's not just making the change, coordinating with everybody else and saying, I want to change the design of this thread pool because it doesn't do X, or you know, this shared pointer. There's 4 or 5 shared pointer implementations that people had added, and this one doesn't quite work, and then things that need changing. All that coordination and effort. Took me a lot of effort to basically ask if we could just take a copy of it, give it our own name, own it, because, you know, that. So you need to be careful of, you know, it's the ownership around this stuff. If it's a thing that your product is delivering, like an SDK, so for REST API, sometimes we've delivered like a domain, a nice richly domain API, and we've got like a model, like a proxy that we can give that uses kind of richer types. And that's part of the stuff that we give out as a kind of feature. We use it internally for testing, and we've kind of made it available. But it's kind of maybe made available with a, hey, look, this is just a leg up. You could use it, maybe just do it to do some spikes to just get some stuff, or maybe you should just fork that part of the repo and take your own. Or if you're using a different language, then it kind of doesn't really help you. But so, you know, there are other ways of doing it. It might be cheaper to fork some code off of a repo and then just go in your own direction and just treat it as a bit of a leg up and then, you know, go in your own direction and see how things go. I think Node ended up with, when I/O spun off from them, and they kind of went in very different directions and then eventually found they needed to merge. But and that was going to be painful because they deviated a lot. But the point was they needed to depart because they wanted to do stuff that couldn't be done, and they couldn't wait for those things to happen. That's the trade-off. Which is more important? Do we want to learn and develop stuff quickly at a cost maybe of a little bit less efficiency in terms of changes later? That's the balance. It's, you know, engineering's a trade-off. So yeah, shared binaries is kind of like a, you know, just think about your dependencies, which of course is Andy's talk, I guess yesterday's lightning talk. It's dependencies. Just keep an eye on them. You know, learn from the likes of LeftPad and stuff like that. Just, you know, be with that. Okay, just last bit. 2 things. I'm glad Seb's here because Seb's the one that got me into Walks with Bear. So thoughts on, you know, the stuff, even as a developer on a daily basis, I kind of read some of the stuff thinking more about the management kind of side of things, but actually I found that they've, even on a day-to-day code basis, the way I think about the code I change. Walking with Bears is about risk, really good. Something it brings out particular, which I wasn't aware of. Risk, again, is seen as kind of in a more pejorative sense, but opportunity risk, the risk of not doing something, is actually equally important, or more important in some cases, and we need to think about, again, should we take on maybe a little bit, do something a little bit different, just to kind of learn more about a problem? Is that actually more valuable than kind of doing it, you know, trying to design? So Walks in Wares is great for thinking about risk, and risk within code changes. And even at a small base. And then the other one is The Goal, which is 1984 or 1980s book, kind of shook up manufacturing with its notions around flow over efficiency, theory of constraints. It's a really nice book because it's written as a novel. You've probably heard of the Phoenix Project. It's kind of it's the same book, but kind of set in an IT context. I personally preferred The Goal. I think more because you kind of get a bit swept away with the Phoenix Project because you kind of go, oh yeah, I've worked in that organisation, or yeah, I've worked with those people, that kind of thing. Whereas I think what I liked about The Goal was it was set in a different industry, so therefore I felt like I wasn't distracted by the amusing IT anecdotes and stuff. But hey, you know, but either way, it's like you can get them for a quid or whatever. But it's a good.
There's another one called Rolling Rocks Downhill.
Right.
Oh. Might like that as well.
Okay. Right.
It's a lot better than the Phoenix Project.
Oh, right. Okay. That's good. Cool. Rolling with Rocks. Rolling Rocks Downhill. Right. Cool. So that's another one to the list. So anyway, two books that I kind of thought were more about management, but actually make me think about code and change in other ways. So I think, and short, 184 pages. The Walks with Bears. Quite old, but cool. That's it really. I'll pause for breath. Any questions, thoughts, observations for 10 minutes or more, or coffee, lunch? Feel free to leave. Stunned silence. You obviously need another caffeine hit. Yes, Burkett.
How do you avoid, okay, so avoiding branches, great idea, love that.
I mean, ultimately, find some way of breaking it down. Sometimes introducing duplication. So there was something that Michael Feathers put in. He did a blog post, and my Google foo fails me to find this. And it was about duplication as a way of decoupling, because obviously, if you do implementation of something, you can go and change the copy of it, and then maybe fold it back in again. You know, we're obsessed with this notion of dry and spot, you know, mustn't represent the same abstraction twice. But actually, duplication allows you to make changes in a copy and to make that change, and maybe fold that back in. That's something I've definitely, you know, I've done before, where we've had to change an implementation because we're not quite sure. It's hard, I mean, but yeah, somehow breaking things down and toggling bits in. I mean, sometimes the things that break things are moving stuff around packages. I mean, working with Subversion again, it's really not amenable to copying files around and stuff, whereas Git's a lot nicer with that kind of.
I found myself in a situation where you're faced with a kind of dead feature branch that has been around for a year. We decided that we would actually bring it onto the main branch as a copy, and then we could work on it on a regular basis. It would be compiled all the time, all the tests would run, and we would nibble off things that we found we could, basically all the changes that have been done to the master need to be replicated on that copy as well, and we could work on in little steps, making these things become more equal until the feature is really the only thing that's different between the copies, at which point you can kind of bring in the toggle to switch over to that one. So that was kind of like the idea to rewrite this dead branch and make it useful in the ending.
Right, okay. So if you didn't kind of catch that, yes, it's talking about using, rather than leaving something on the branch, taking a copy of the code and keeping that alongside, but within the same branch, but still running tests and basically folding the features in piecemeal. Presumably the bits you pick in are the bits you think are most valuable to bring across and slowly kind of like, kind of improve stuff. Yes, Giovanni.
Based on what you said, sorry, for the big change to the code, long feature branches for that. In my experience, when that happens is when you are making a change of which you are not quite sure where you want to go. Yeah. So in those situations, I will go prototype the change, a spike. Okay?
Yes.
If the direction is the correct one, once I'm confident about that, then I work on master, continuously committing small bits of things at all times.
Yeah, so using spikes on feature branches, branches for spikes is definitely a thing, because you often pull the code apart. You might want to change radical things. You create a noise in the history if you turn out to revert it, which is kind of a little bit painful. But
before doing the change, because if it is a long thing, lots of code of them, people that do that in a branch is because they are not quite sure about the direction. So investigate the direction first. Once you know what you want to do, then do that. But always committing to master.
First, yeah. One example we did, people don't often change databases. On one project, we switched from one database to another database, and we did that whilst the system was still running. Brought in an implementation that ran on the database we were going to. I mean, luckily, they were both document-oriented, so paradigm-wise, the code still worked pretty much the same way, where you pass it in closures, put in the document, applying the changes again. So at least from paradigm way, the code worked in a similar way, but ultimately we could basically bring in the two things, and we had tests running against the old database and the new database to make sure the features remained in thing, and then kind of like unwound them again, which is kind of another example of that copying. We didn't literally switch from one to the other and delete the old code. We kept the two running in parallel because it was a safer change. Cool. I thought somebody else had a hand up. But no? Yes, well, feel free.
You're talking about books and saying they're rather old, but I don't want to say that, because old doesn't mean anything wrong. But there do seem to be older books looking at what problem are we trying to solve. Are there any around? What is it with the books now? Are they just looking at a solution without having to step back? There's things like people wearing. I know there's classics that have not been replaced.
Yeah, so yeah. If it's not at least 30 years, I'll know. Yeah. So again, observations around literature and reading that you know the real classics like people wear, Waltzing with Bears and you know even the Goal. I mean, obviously that got updated and with obviously another version of it. So some things are books are sort of updated, but a lot of the stuff is still sage advice. I think Adrenaline Zombies and Template Junkies, which is another Tim Lister book, has got, you know, that's a more modern take on patterns, which again folds in some of their older work. I think Jerry Weinberg, I think, seems to have kind of rewritten or at least updated a lot of his old stuff. I suppose I just haven't read the newer versions of maybe the stuff to know whether there are revised copies of some of that stuff, because I guess I've tended to go to the original source, and because it's cheaper and I'm a skinflint. And so once I've got that, I don't necessarily look for the kind of modern thing unless it's particularly impressive. No.
Going to talks by people of a similar vintage, but I haven't seen anywhere that fills that slot.
No, I remember asking Steve once about good OO books, because it's like it felt like it was still Booch and Meyer and even the Arthur Rahl's object-oriented design heuristics, which I think is still 96, something like that. It feels like, again, it's another area where there doesn't seem to have been any big kind of, you know, modern take on old things. So I don't know, maybe we just keep finding out that they are still good enough. I don't know. I think certain people are definitely Dan North is certainly you know, a big proponent, I think, of a lot of this stuff, isn't he? So I think hopefully, you know, people like him will maybe right. So you don't think he's in the right age, not? Anybody else that you think might be up for?
There are books, you know, so for the Prague Prog has loads of ones coming. So if you think about maybe the nature of software development by Ron Jeffries came out a couple of years ago. Giovanni was talking about X-ray. What was it called?
Software design X-ray.
Software design X-ray, which actually addresses the question that was asked just now about how to restructure large systems. So they're there. It's just that I don't think they've got the critical mass.
Yeah. I think George Fairbanks' Just Enough Architecture seems to be gaining traction as a book. Say it's on my shelf ready to go, but that feels like maybe that would be another classic. I mean, object-oriented software guided by tests is probably one of the other modern classics that seems to have gained a lot of traction as another thing. Sorry, did you? Are you stretching? Yawning. I thought I saw a hand go up and down again. Cool. Well, there you go. I don't have a book. I'm not going to be the one to write it either, because I'll just read the ones on my bookshelf. Oh no. Maybe I'll write a book about might be better to do puns, that's about it. But stuff that I've done, blogs, articles for CView, that kind of thing. So that's all I can offer as a thing. But that's it, cool. Go and get some lunch. Snooze. Thank you.